So let's talk about the heating curve. As you can see, what's the meaning of heating curve? Heating curve, we're going to study the behavior of matter if we start applying heat on the material. So let's start with drawing the heating curve. We're drawing heating curve like the y-axis and the x-axis. The y-axis, okay, I mean the vertical one, represents the temperature, whereas the x-axis represents the time in second. Here we have a substance, which is a solid, and this solid material, okay, I applied heat on this solid material. So what will happen if I apply heat on solid material? I just want to show you from A to B. This material is solid. Okay, I'm increasing the temperature. What will happen as a result of increasing the temperature? Look at the description. It says that increasing the temperature in this area leads to make a lot of vibrations of these solid particles. You have to remember that the solid particles do not move, they only vibrate. They only vibrate. Okay, suppose that you have a piece of ice, you are melting this piece of ice, the particles of ice will start to vibrate, okay, as a result of applying heat. What will happen after that? We will go from area B to C. What is happening in B to C? What's happening in B to C is melting a process, And the state of matter in B and C, let's say it's between like solid and liquid mixed together, okay? Like solid and liquid together. At BC, we can conclude and measure the melting point of my material by writing a horizontal line and just read it from the curve. But miss, what is going on in B to C? What is happening? Look at the description up. The forces of attraction between particles are weakened, so the particles begin to slide over each other. Okay. In the previous slide, we just knew that we have solid. Solid vibrate when we apply heat. But when they start to become liquid, the forces of attraction are become weak and then they will start to break. Okay. In this case, the motion of material will become, let's say, liquid. The particles start to slide over each other. Slide over each other is the motion of liquids. It's the motion of liquids. Okay. Miss, why do we have fixed line from B to C? Why it's not increasing? Because you have to break down all of the attraction forces, okay, and then raise the temperature. In this case, from B to C, we have solid and liquid material. In this case, solid and liquid. After that, we have from C to D. We are increasing the temperature in this case. The state of matter in this case is liquid. The state of matter is liquid. And we notice that there is increasing in the temperature. What will be the motion of particles from C to D? You will say like from C to D, the state is liquid. Liquids, they slide over each other, okay? They slide past over each other. So this is the motion of liquid. The motion of solids, it's only vibration. Okay. After we completely complete our material to liquid, what will happen if I complete or increase heat? What will happen now? What will happen is boiling process. And we have fixed line the same as in the melting. We have from D to E. From D to E, the boiling process takes place. And if you want to determine the boiling point, you just can draw horizontal line and read it from the graph. I will see you this later. In the boiling process, the attraction forces in what? In liquids. They will start to weaken and then they will start to break down and they will start to change to gas. If I ask you what will be the state of matter from D to E, the state of matter will be mixed between liquid and gas. Liquid and gas. Because we have, let's say, kind of boiling, we still have liquid and we still have gas at this point. Okay, Miss, why it's fixed line? Why do we have fixed line in DE? The answer is, in this case, you have to break down the attraction forces between liquids instead of increasing the temperature. So you will start to break down all of the attractions and then increase the temperature. Look at this. As a result of breaking down all of the attraction forces in liquid, the material starts to become gas. And as we can see, the state of matter from E to F is a gas. What is the motion of gas particles? They move randomly. What is the motion of liquid particles? They pass a slide over each other. What is the motion of solid? They don't move, they only vibrate. Okay. So here we have increasing it from E to F, and this is the gaseous state. Look at the lines, look at the boiling point, look at the melting point. The boiling point is 150, so I can, let's say, determine that. And look at the 30. 30 here, as we can see, this is the melting point. Okay, so this is the heating curve.